My name is Javier. I'm gonna present a tutorial about creating a finite element mesh for the pavement simulation using GiD. We're gonna model only two slabs, and this is the top view of the model. And here we have a cross-section view. Note there is a joint between two concrete slabs. And finally, this is the gear configuration that we're gonna use to apply surface tractions. Okay, so let's begin by open GiD and creating a set of points that will be used to create nerve surfaces, and later will be used to create a volume that represents the domain. We can click on geometry, point, and then we specify the coordinates of the points. Now, as you can see, we have created a set of points that will be used to define nerve surfaces. So we click on geometry, create nerve surface by points, and then we create all of them. Okay, so now we've created all the nerve surfaces, and please note that we did not create a surface in the region that represents the joint. And finally, it's always good practice to delete duplicated entities that may have been created during the creation of the surfaces. So let's click on delete duplicated entities and click OK. Note that I have three different layers representing the three different materials, and also I have a few regions which are going to be used to have a better control over the mesh discretization parameters. And finally, note that there is no surface in the joint. To extrude them into a volume, we're going to click on Utilities, Copy. Copy. The entity type is a surface in this case. The transformation is a translation. These surfaces live on the 0, 0, 0 plane, and we're going to extrude them by 6 meters into a volume. We select all of them, we click on Finish. And now we can see that we have a volume that is ready to be meshed. Note also that there is no volume created in the joint region. The step is to create the elliptical surfaces that represent the gear configuration as it is shown here. So let's create a circle first. Geometry, create object, circle. We need to specify the center for the circle, so let's use the coordinate window. Center in this case will be 2.1565. Y coordinate will be the y coordinate of the top surface, which in this case is 0.20, and the z coordinate is 0.81. We click on apply. Then we select the y-axis as the normal for the circle. We click on OK. And we have to specify the radius for the circle, which in this case is 0.277. So we have created a circle. Now we have to change its aspect ratio to create an ellipse. We click on Utilities, Move. We select a surface as an entity type. The transformation is going to be scale. The center, we specify the center of the circle, 2.1565. One is 0.2, 0.81. And the scaling factor. So as you can see, the scaling factor can be obtained by dividing this value by this one, which in the x direction is going to be 1, but the scaling factor has to be applied. I'm sorry, the scaling factor has to be applied in the x direction. We click Select, Finish. And now we have to copy this ellipse. We go to Utilities, Copy, Entity Type is a surface, and by translation, 140 centimeters in the x direction, which is 1.4 meters. Select, Finish. And now we have to repeat the process in this direction. And let's make 2 copies. So we are done with the gear configuration. So it's quite similar to this finite element mesh that I have here. So what is left? We need to go to Geometry, Edit, Intersection of Surfaces. We select the top surface. And we also select the elliptical surfaces. And we click on Escape. And we're done. Now the elliptical surfaces are part of the top surface of the model. Before proceeding with the mesh, it's always good practice to delete duplicated entities that may have been created during the intersection of the elliptical surfaces with the top surface of the domain. So let's click here, delete duplicated entities, and we click OK. And as you can see, GiD deleted 6 duplicated entities. Now we are ready to proceed and assign different material properties for each layer and apply boundary conditions to the model. Now let's assign material properties to each layer of the domain. Let's change the view. And now let's click here on Assign Body Materials. Let's create a new material for each layer for the base. And please use the actual value of the Young modulus and Poisson ratio. And we click Volumes, and then we select all the volumes at the bottom layer. We click on Finish. Now we repeat the process for the concrete. Again, please make sure that you are using the actual values of the Young modulus and Poisson ratio. click volumes and select the middle layer. And finally, let's create the last material for the top layer. Just for double checking, we can draw all the materials, and as you can see, we have a domain with 3 different materials. We click on finish and close. We can also specify boundary conditions. And for this video, let's assume that we fix all the degrees of freedom at the bottom surface of the domain. So we click on Assign Displacement Conditions. We click on Surface. Let's create a new tag, bottom BC. Let's constrain all the DFs, and then assign. Now we rotate the domain, and we select all the surfaces at the bottom of the domain. This one. And finally, this one. We click finish. Again, we can draw the displacement constraints. And as you can see, we have constrained all the displacements, all the degrees of freedom at the bottom surface of the domain. And finally, we can also apply surface tractions. So we click Assign Force Conditions. We click on a surface. We create a new tag. And this is just for the video. I'm going to use random value. Then we click on Assign. We select all the 6 surfaces. And we click on Finish. To check if everything is working correctly, we click on Draw and all prescribed forces. And we have prescribed surface tractions. At this point, we are ready to create a mesh. We have to specify some mesh controls. Basically, because the main goal is to guarantee that we have a structured mesh in the region where we expect crack propagation. So in order to do it, we need to click on Mesh. We first select the element type. We click on tetrahedra. We select all the volumes. We hit Escape. And now let's assign some mesh controls. Let's click on Mesh, Structure, Volume, Assign Number of Divisions. We select these 3 volumes where we need a structure mesh. Now we specify the number of cells. So from this drawing, we can see that we have 4 by more or less 15. So let's do first 1 here. If you select this one, since this is a structural mesh, this one will be automatically selected. We hit Escape. We use 4 here. Escape again. And 15 for this direction. Escape. And let's say we have 300 in the Z direction, which is this one. Escape again. Close. And we are ready to generate the mesh. Let's give 0.2 meters as an average element length. And now the mesh is being generated by GiD. We click on View Mesh. Let's change the render to flat. And as you can see, we have a fully structured mesh in the region where we expect crack propagation. Note that we can specify additional mesh controls to have a better discretization in the finite element mesh. So for instance, we can increase the resolution of the elliptical surfaces, and we can also have a structured mesh for the outer surface of this portion of the domain. So let's start by assigning a mesh control for the elliptical surfaces. So we click on Mesh, on Structure, Assign Size and Lines. Let's use this value as reference. We click here, and we hit Escape, Close, and remesh. So as you can see now, we will have a better discretization of the elliptical surface. The second mesh control will be used to have a structured surface in this portion of the domain. So let's click on Mesh, Structured Surface, Assign Number of Divisions. We select 3 surfaces, and let's say we want 35 divisions in this direction, and 5 at the bottom layer, 4 at the middle one, and finally 3 at the top one. Escape, close, and remesh again. It's important to note that this structure mesh only applies to this surface.